Hello, I guess I'm audible. Okay. So, hello everyone. Today in this video, I'm going to discuss the two left questions. This target DSA T4 contest. I have already discussed problem one, the max discount one, and problem four, which is mystic arrays. Both of those problems were originally from DSA, and today I'm going to discuss the problem two and problem three of the T4 contest. Both of these problem two and problem 3, which is this tree problem, prime safe node assignment in trees, are originally from Google OA. So I guess most of you have already seen this problem and would have I guess tried at least once. So without wasting much time, let's get started with this problem. Yeah, this problem was in my set only. Okay, so in this problem there is a guy. Basically, you are ambitious entrepreneur. Basically, there is a business of, you can say, a business or a firm which is having n items in stock, and each item is having individual selling price and their delivery cost. Okay, so eighth item, the selling price is CI and delivery cost is DI. Okay, it is given to us. If a customer orders sorry, multiple items, the delivery fee for each item in the order is determined by the minimum delivery cost for all selected items. Basically, it is saying, if let's say I'm having I1, I2, all the way up to IN as my n items. Let's say from these n items, uh, I'm having m items in my order. Let's say I1, then let's say I3, I4, then I7, and any m items. Then in that case, uh, the selling price for each item will be same as its original selling price, but the delivery cost for each item will be the minimum of all the selected delivery prices. Basically, minimum of all those D1, D3, D5, D4, D7, and all these. I will find the minimum out of all these delivery cost, and that delivery cost will be same for each item in the order. Okay, so this is the problem, and what we have to do in this, if you can deliver exactly m items, your task is to decide which items to deliver such that the total profit, which is selling price of the selected items plus the flat delivery fee, is maximized. Okay, basically the total profit is something which is summation of selling price and delivery cost for all the selected items, right? And we have selected m items. We need to maximize this thing. M and n both are up to 10 to the power 5, and cost price and delivery cost are up to 10 to the power 6. Okay, nice. So let's try to solve sample test case first. Okay, yeah. So this is the sample test case. Put format is n, then m, then again for each n ith line, the cost price and delivery cost. Okay, so n, m, 3, 3, 6, 8, 2, 5, and 1. We are having 3 items and we have to choose 3 items from these. Basically, that means we have to deliver all these items. Okay, let's quickly see the minimum out of all these delivery prices. The minimum out of these is 4, right? That means 4 will be the delivery cost for each selected item, which is which is all the items in this case for each selected item. Okay, let's see. In this case, the total profit will be summation of the selling price, which is 6 plus 2 plus 1, then summation of delivery cost. Delivery cost for first item will not be 8, it will be 4. And for second also it will be 4, and for third also it will be 4. So the total profit will be 6 plus 2, 8, 8 plus 1, 9, 9 plus 12, which is 21. So that's how you get this solution. Okay, let's go to next part. I have already written this. The rule for this problem is if we are delivering multiple items, then the delivery cost taken for all the items is same. That is the minimum of all the selected delivery costs. Okay, okay. Basically, uh, total earning, which is total profit, is this summation of selling price, then m times the minimum of delivery cost, right? Okay, and we need to maximize this expression. Okay? Whenever you see these like mathematical expressions which are involving some kind of like some number of elements, and you need to maximize or minimize these. So the first thing that should that should strike to your brain should be use of sorting. Let's see if sorting can help us. Let's say I am creating a array of pairs where pair will store uh, delivery cost and selling price, and I will sort this on the based in decreasing order of delivery cost. Why? Because I'm getting hint out from this part, because I need the minimum of the selected item, right? If I let's say if I am sorting this array in decreasing order, the I will explain with the next part, because this step will become more clear in further steps. Let's see. Let's see the first test case. Yeah, this was the array which I have built. This array is delivery cost, comma selling price, and after sorting on the basis of decreasing order of delivery cost, the sorted array is this: 8 comma 6, 5 comma 2, 4 comma 1. Okay, now uh, I have to I have to choose all the three elements. Directly I just have to iterate from left to right. Just I have to add the selling prices, which is 6 plus 2 plus 1, then 3 times the minimum of 8, 5 and 4, which is 4 only. Basically I have sorted in decreasing order of delivery cost, so that it should be easy for me to find the minimum of delivery costs. Let's see another problem, another test case where the array is something like this: 4 comma 1, 5 comma 3, 6 comma 2, 3 comma 6, 2 comma 5. After sorting in the decreasing order of delivery cost, the array I will get is this. Let's say uh, window size, or you can say the m value for this is m value for this seeded see uh yeah 3. Okay, m value for this is 3. Okay, basically I need to consider all the favorable 3 sized windows so that I can maximize that expression. And that expression is nothing but m times the minimum of selected delivery cost plus summation of selling price. But selling price is something which I need to maximize, right? Okay, so uh, I have created minimum heap, minimum type of priority queue, so that whenever I get a window of m plus one, of m size inside this priority queue, the topmost element should be, yeah, topmost element should be the minimum one. So that after removing that topmost element, I will be having my best selling prices for that window. Let's try to simulate through this test case. Basically, I was having this array, delivery cost comma selling price. Okay, right. M is the number of deliveries, or you can say number of items I need to choose. Let's see, I have created a minimum type of priority queue. Let's discuss this thing. Wait, let's see. Okay, so initially priority queue is empty. In priority queue, I am just storing the selling prices of the selected items, or you can say of the. I will iterate from left to right. The first item is this. Its selling price is 2. 2 is inside the priority queue now. Okay, just total selling price I can update by 2. Then I have reached this item and window size is 3. Now 2 is already there. I have to push 3, and this is min type of priority queue. So the priority queue will look like 2, 3. And now window size is 2 currently. Now let's go to this. So 1, 2 and 3 are already there. So priority queue will look like 1, 2, 3. And apart from this priority queue scene, total selling price is also getting incremented by 2, then 3, and then 1. When it reaches this point, my window size is 4, right? That means I need to uh, press the window, or you can say I need to remove some element. But which element should be removed? I should remove that element which is contributing the least selling price, which is this, which is at the top of priority queue, right? So whenever my window, or you can say the priority queue dot size, gets equal to m plus 1, I need to remove the contribution of the topmost element from total selling price, right? So I have subtracted this and I need to pop this up, popped it out. So now inside my priority queue, 2, 3, 6 are there, and their total selling price is also already there. Okay, and one more thing, uh, I have considered window up to this, right? I have removed this. So for this window, my current index is this, right? And for current index, the delivery cost is this 3, which is, you can see, it is the minimum out of 3, 4, 5, and 6. So my current index delivery cost is the minimum one. So the total profit for this particular window of M selected items should be this total selling price plus M times this array of I dot first. This is one of the case of M selected items. I can update answer as max of answer comma this temporary answer. Are you getting my point? So here I have just tried in that part. So the overall algo for this kind of problems is whenever you see that you are having n items inside your array, and you need to like for each item you are having your ci as selling price and di as delivery cost, and you need to choose m items from these such that these are the selected items, and for all the selected items selling price will remain same, but the delivery cost will be minimum of all the selected ones, right? So for this kind of problem, first thing that you should do is sorting. And the hint for sorting on the basis of decreasing order of uh, delivery cost is, I got that idea from this part, where, yeah, this part, where I just need the minimum out of all the, basically I just have to consider you can say a subsequence window, and whose minimum value of delivery cost I need. For that, I have sorted this delivery cost, comma selling price array on the basis of decreasing order of delivery cost. And after having my sorted array, I just need to iterate over this array from left to right, and I need to maintain a minimum type of heap, or you can say min priority queue, for selling price, so that whenever my priority queue size gets greater than window size, I just need to pop this minimum selling price so that I can maximize the overall expression. And I just need to remove its contribution from total selling price by this part. And then the total profit, the current, you can say the temporary profit or temporary earning for this particular set of subsequence of M selected items will be that DSP minus the contribution of that popped out element plus M times minimum of delivery cost, which is just ARR of I dot second. If you are getting this point, it's nice. If you are not getting this point, I would suggest you to do try run on any of your uh, test cases, any of the test cases of a problem. Definitely will get the point. So let's quickly go through the overall algo for this problem. I have initially built delivery cost, comma selling price array, then sorted that array in decreasing order of delivery cost. Then I have maintained a min heap for having selling prices and removing the minimum out of that window whenever the size of variety queue becomes m plus 1, which I have already discussed, and then I updated the answer using this array, this expression. And after all these steps, I have returned the answer. So the overall time complexity for this solution will be n log n for sorting part, n log m for priority queue part. And space complexity is over 2n plus m, and n and m both are up to 10 to the power 5, so space and time complexity is not the problem here. Let's quickly see its code now. Wait a second. Yeah, this was the problem. Yeah, so I have used long and pair. For pair, I have used PLL as my macros. Then I have taken input NNM, C and D array. I have created array of pair, array dot push back Ti comma Ci. Then I have sorted on the decreasing order. I have created priority queue, min type, decreasing order of delivery cost. And this is min type priority queue to handle, or you can say to remove the contribution of minimum selling price whenever window gets exceeded, or you can say window size which is m plus 1. Okay, so answer I have, this is total selling price, this is answer window. Okay, I am iterating for this array, over this array. Selling price I am incremented by the selling price, which is array of I dot second, because array of I dot first is the delivery cost. I am pushing this inside the priority queue and updating the window size. Whenever window size gets if window size is less than m, I don't have to do any of this stuff. If window size is equal to m, then I just have to update this stuff. And if let's say window size gets m plus 1, then I have to subtract the, like I have to decrement the window, and I have to remove contribution contribution of minimum selling price of that previous window, right? I popped the element, answer is equal to, again I have updated this and just return the answer. The test case are running. Okay, so that's all about this problem. If you are having any doubt, you can discuss in Algo discussion group, or you can ask anything in section as well. So that's all for this problem. Bye bye.